guys, my name is Fifi and welcome to the third video in my Coding for Beginners course. Today we will continue learning about variables and discuss their basic forms. A quick overview on the lesson includes how computers represent data, numeric data types, and mathematical operations. The big idea for this video is that data is categorized into different types in order to represent information precisely. Okay, so now we're going to talk about how computers represent data. Data is processed, then allocated to memory, which is essentially dedicating sections of RAM to storing information from a program. You don't really need to worry about how this memory is allocated, but you do need to know that this information is represented much differently than what you end up seeing on your screen. All data is translated into binary, which is a base 2 system made up of ones and zeros. In this example, the segment of binary represents 5, and each digit represents 2 to the power of its place, starting from 0. The first section represents 1, and the third represents 2 to the second, which evaluates to 4. And when you add up the values, it translates to 5 in decimal. However, another segment like this could represent a character like A or F. And at the most basic level, the programs we write are also binary. When we press run, the higher level code is translated into a low-level language that computers understand, called machine code. Machine code is low-level because it is the direct language of the computer and is relatively hard for humans to read and understand. Modern programming languages like Java and Python are much more similar to conventional English and are high-level because they are abstracted, meaning that you can do a lot of things automatically without worrying about how they are being done. You don't really care how a piece of code works as long as it is efficient and gets the job done. An example of abstraction is like driving a car. All you really have to do is brake, accelerate, and steer, but you rarely have to worry about the actual mechanics behind the car that allow you to do these three things. Now we are on to data types, which are exactly what they sound like. They are categories that we put information in. Some languages do not specify the type in their variables, but pretty much all have the concept of a variable and a data type. Numeric data is split into whole numbers and decimals, and as you can see, there are multiple ways to represent each of these. So why do we have multiple types if we only have 2 categories? If you remember, binary needed 3 digits to represent the number 5. Decimal only needed 1. This means that binary requires a lot more digits to represent numbers, especially as numbers get bigger and bigger. Binary is grouped into sections of 8 bits, or binary digits. These groups of 8 are called bytes and can represent 256 values. A decimal number with 8 digits could represent just short of 100 million. Since languages are translated into binary, you don't want to use more or less bits to represent data than you have to. This is where the multiple types of whole numbers and decimals come in. Each has a limitation on the largest number you can store. Whole numbers have 4 options, but an int, which is short for integer, is the most commonly used type. Decimals are more interesting. They're limited in how many numbers past the decimal point that you can store. Java doesn't make you specify how many numbers you can have in front of or behind the decimal point, and because the decimal can float around, non-whole numbers are also called floating point numbers. The float type is less commonly used than the double. Double stands for double precision, meaning that the numbers you can store can be twice as specific. For example, a double can store up to 16 decimals of pi, whereas in a float you would have to round much earlier, at 7 digits past. You can always convert a smaller data type like a byte into a long, but the other way around is not possible because you can only store so much. Similarly, with floating point numbers, you shouldn't try to fit a double into a float because the number becomes less precise. Numerical data can be operated on just like a regular number. Today we're going to talk about the 4 basic mathematical operations, in addition to one that is used a lot in computer science. I am going to print out the integer value of 12 plus 4, which gets us 16. Now I'm going to print out 9.5 plus 3.7, which gets us 13.2. While this is great, the same operations with variables representing the values can yield different results. Alright, So let's create a variable for all of these numbers, and let's say that we are representing the amount of money that you and your friend have. The integers are dollars in cash, and the doubles are dollars in coins. Let's name the ints my cash and friend's cash. In the variable names, notice how words after the first are capitalized. This method of naming things is called camel case because of the bumps that each capital letter has in between the lowercase ones. Camel case is a style convention which is really just an accepted format agreed on by Java programmers in order to make their code more readable. You can also have upper camel case, which is where every word, including the first, is capitalized. Alright, now we're going to name our doubles, my coin and friend's coin. We have already declared our variables, which means that they exist, but now we're going to initialize or assign them to values. My coin and my cash will be 9.5 and 12, and our friend's coin and cash will be 3.7 and $4. Alright, so now we're going to print out the sum of 9.5 and 3.7, but replace the numbers with their corresponding variables. Everything works fine, right? Now we're going to add my cash and my coin together to see my total. We get $21.5. But let's say I don't want to print it. I also want to remember the total. Now we're going to update my cash to store the total amount of cash and coin. Notice something weird when we print our variable though. Our total appears to be $21. This highlights the concept of imprecision. Ints just cut off everything past the decimal point. Imagine if your banks or your workplaces did that. This is why we use doubles for any value that you can't guarantee will be a whole number. When we change the type of my cash to a double, then you see that we get 21.5 as expected. This is the same with multiplication, division, and subtraction. Make sure to store in a double if you are operating on both an integer and a decimal. Your challenge for today is to represent how many hours you worked to make $50 given a wage of $5 an hour with a tax of 7.5%. Just try your best and make sure to use at least 2 variables and to print out your final answer. I'll be going through my solution in the next video. If you want to refer back to the problem, it will be in the description below. Modulus, or modulo, is the last mathematical operator. Modulus finds the remainder of one number dividing into another. This can be extremely useful for many purposes, such as extracting the digits from a number or to see if a value is even or odd. The remainder can never be bigger than the number that is dividing. The first example is mod 10, which always gives you the rightmost digit in a number. 1532 mod 10 equals 2. The second example is mod 2, which also tells you if a number is even or odd. 4 divided by 2 is 2, which is a whole number. That means that there is a remainder of 0 and 4 is even. Notice that mod 2 only results in the value 1 or 0 because those are the only non-negative numbers below 2. The last is 48 mod 5. The closest that 5 goes into 48 is 8 times. 8 times 5 is 45, and 48 minus 45 is 3. So 48 mod 5 is 3. And with that, you have reached the end of this video. We have covered numerical data types, how computers represent information digitally, and mathematical operations. Thank you guys for watching if you stayed this far, and please like, subscribe, and turn on your post notifications for more tutorials. If you have any questions, leave them down in the comments below. See you in the next video.